Hi friends, my name is E, and today we're going to be language hacking on Gleam. For folks that don't know, Gleam is a new programming language that is both safe, friendly, performant, and actually has Erlang as one of the targets it can go down to. I've been working on Gleam and hacking on it for the past couple of weeks, and I figured I'd record a video where I kind of go through my process of how I kind of find a ticket, take it off, and work on it. Gleam is written in Rust, but full disclosure, before working on this, I've never done Rust before. So if I make any mistakes during this video, feel free to comment below and let me know what I could have done better. But let's jump into it. So one of the nice things that Gleam has here is it has a really well curated issue tracker. And inside the issue tracker, we actually use the label good first issue. And this is what I've been kind of using to kind of find issues that may be working for me as someone new to the language, new to the project, new to Rust, and try and find things that I could take off and contribute back to the project. And here's the one that I think would be good to work on today. So as I mentioned before, Gleam actually can compile down to both Erlang and JavaScript. But one of the things that it does with Erlang is it actually adds spec type comments on the Erlang. So basically in Erlang, it doesn't have a real type system built in, but you can annotate your code with these kind of types, and then you can run a side program to actually interpret those types and call out any compile time errors. JavaScript, we don't have access to that, but what we do have is TypeScript. TypeScript is a language superset on top of JavaScript that allows us to add types. And what we can do here, as it's saying, is basically we can generate TypeScript type definitions that can actually sit next to the JavaScript code that's emitted. So we're just going to kind of go through that. But before we jump into that, we should probably talk about how Gleam works underneath the hood. So the Gleam README is really nice and actually has this compilation flow built in. But as you can see, if we were to trace how source code gets generated and emitted eventually to JavaScript, you can see that the source code goes into this parser. And the output of that parser is a untyped abstract syntax tree. Those syntax trees are then sorted in dependency order so that we can make sure to type check them in the correct order. So those untyped ASTs basically go through a type checker. And the output of that is a typed abstract syntax tree. And that typed AST is basically sent to the code generator, which has a target. So either Erlang or JavaScript in this case. And then eventually we will have this code generator generate some code, and then finally it will go through a pretty printer. So the emitted code looks nice and pretty. So let's just jump into the code and see how we can do this ourselves. So inside here, all I've done is open up the Gleam source code. And here you'll see top level, we have this compiler CLI. So this is the actual project in Rust that is managing the CLI. And what I've done is opened up the build file, because what we need to do is ultimately hook into the build system. So from here, you can see, if you don't know Rust, as I didn't a couple weeks ago, this may look like gobbledygook, but really what you need to just kind of tell is these double colons basically give you kind of like namespace function call or accessing some sort of attribute. And you can see we can kind of skip all of this bits, and the important parts here is this project compiler. So we kind of generate a new project compiler, and then we call the .compile function. So let's go see what that looks like. So inside this compile function, we are given the project compiler itself as self. And you can see it does some sanity checking, some telemetry, but eventually it's going to call compile root project. And so let's go see what that looks like. Down here in compile root project, ultimately, we're just going to clone the config and then call compile Gleam package. This is kind of my process of just tracing the code, see where it leads me. So inside compile Gleam package, you can see that we're eventually going to build up some output paths and library paths and artifact path, and then eventually pass that down to a package compiler. And if we look, we eventually call package compiler.compile. And the target here is either going to be Erlang or JavaScript. So let's keep tracing this. So let's go to the compile function, and we can see inside the compile function, we're now going to be doing exactly that diagram that I talked about. So first things first, we're going to parse the incoming sources. We're then going to sort those into kind of dependency order. And then finally, we are going to pass that untyped AST into a type check function, which is going to then pass us these typed AST modules. And then finally, we're going to perform code gen. And so this seems where we need to kind of hook in. Inside perform code gen, you can see that this is where we now switch on what type of target we're going after. So if the target's JavaScript, we're going to perform JavaScript code gen. Pretty simple. And finally, we are now in the perform JavaScript code gen, where you can see we actually call into this JavaScript module in the render function. And this will ultimately render to the IO. And inside the render function, we are now, for each module in the typed AST modules, we're going to call this JS module function. And what the JS module function does is it will actually call into the JavaScript Rust module and call the module function. Sorry for the confusion. And eventually here we'll actually report this result on how it did generating this module. So this is exactly where we need to kind of hook in. So what we're going to do is actually back up and actually go back to the render function. And what I feel like what we can do here is just add a TypeScript definition. And if I misspell things, I apologize. I am not a great speller. So I figure we can call TS definition TS definition. And we can basically then copy paste this JS module. But instead, here we're going to start generating some TypeScript. So we're going to take all the same arguments, but for the file that we're going to generate, instead of doing an MJS file, this is going to be a .d.ts. So for folks that don't know, .d.ts is what you put your TypeScript definition files in. And then we, instead of calling JavaScript module, we're going to call TypeScript definition, passing it all the same stuff. And we're going to change the tracing so that we can say that we generated a TypeScript definition. Easy peasy. Now we're going to say, hey, there is no such thing as TypeScript definition, and it's absolutely right. So let's jump into that JavaScript module here. And you can see this is where the actual compilation happens. So this is what's going to kind of walk through that typed AST and then start emitting JavaScript where it makes sense. So, you can kind of see in this AST, as we find a top level function, we're going to generate a module function, which is then ultimately going to start saying, if it's public, it's going to export it. Otherwise, it's going to be private to the module. And you can kind of see what we're doing here. We're just kind of building up the string of JavaScript after, walking through the AST of the type file. What's nice about the TypeScript definitions is, as you can see, when we get into a when we get into a function here, it eventually is going to call this function body. So it's actually going to go through all of the expressions inside that function AST and have to turn those into into JavaScript. But for us, we don't need to do that, because all we need to do is look at the top level statements and turn those into TypeScript definitions, because the inner workings of how that happens, the definition doesn't care about. It just cares about the inputs and the outputs that are coming in. So the arguments and the return type. So let's go to the bottom here where that JS module function is defined. Nope, right here. And now we need to define TS definition. Again, we're taking all the same arguments. So we're getting our type module, our line numbers, where this is going to, ultimately the underlying source code, and where we're going to write to. So some sort of writer here. And instead of calling the generator, we're just going to call out to TypeScript. And I figure what we can do is create a TypeScript module inside Rust so that we can hide all this in one other place, not to dirty up this file any further. So the way how that's going to look is we're going to open up the JavaScript folder here. We're going to create typescript.rs. And then we're going to import that over here. And now we can start copy pasting some code. Because what's nice is this already happens in Erlang. So we can kind of find out how Erlang is doing this when they're emitting their types and kind of copy paste them and make them useful for in a TypeScript environment. So let's take a look. So we need to define a new here. Which is going to take in those line numbers. And let's just kind of look at how the generator does this so that we can just kind of copy paste its bits. I don't think we're going to need a usage tracker, though I could be wrong. We'll see. Let's just take off that module scope as well for now. And in fact, let's just call this compile. I don't think we're going to need an underlying function. Well, if we're going to do that, then we don't need this new either. So we're just going to pass these two things in to the compile function here. Is not going to emit self. And what we also need to pass in is that writer, so that ultimately we can write to something. So let's go grab that again. Sorry for jumping in a bunch of places. So we also need to pass in compile module. Let's just pass all of this in. Module, the line numbers, the path this is going, the source, and the writer. And this pretty print is not going to be on what we have. So what we need to do is actually say, let's turn this into a result. And then let's just do generator, new, just kind of like the other one. You know what? Let's just ignore the pretty printing for now. Okie dokie. And now this is basically the exact same interface as the previous one, so we can just kind of copy paste it and rename this compile. All right. So we finally have our kind of clean file. Now it's going to be complaining about, hey, I don't know what any of these are, which is very fair. So we'll just start importing these. All right. And all right, we're clean. Yep, now it's just complaining that, hey, this looks like it should return a result type, and it's not. And compile is complaining that, yes, it says it will return a return type, but it's currently returning unit. All right, so now we're finally got our kind of clean file ready to go here. But before we kind of have to start typing all this stuff out, let's take a quick detour into the Erlang module to kind of see how this thing does its type emission. So we just search for type. We'll see that we're referring to a type module, some statements. Looks like we're pulling out the underlying type into some of these things. I believe there is a type printer. Yeah. So let's look for the definition of this. So this type printer has all of these functions inside it. So print var, print prelude type, print type app. So this is exactly kind of what we want. So the type printer, what it does in this Erlang module here is it takes in underlying Gleam types, and we'll go into that in just a bit, and ultimately kind of prints them out as the Erlang equivalent. So you can see this here, it's doing an any type. If we went down to the prelude types, nil becomes lowercase nil, int becomes, or UTF code point becomes integer, string becomes binary, bool becomes boolean, etc. And you can kind of imagine what exactly this will look like for TypeScript. So what I'm going to do is shamelessly just steal this. And then we're going to go to our TypeScript. And let's just paste this inside here. Now, what I think we're going to do is just start deleting some of these inner bits, because I don't think we'll need them. But, you know, we'll see. Yep, and get rid of this generic. Get rid of this with var usages. What we want to do is basically prune this down so that we can just kind of wrap our heads around it. And let's also go through and import some of these missing types as we go through them. So we need our type. We need our prettier document, because that's what we ultimately need to be generating here. We need our type var, also from the type module. Let's see, anything else that we're kind of needing? Obviously, a lot of errors still yelling at us here. I see. So we're referring to these fields that we've now removed, so we got to get rid of those. Well, we'll touch them once we start to refactor. Okay, we need to import arc here. Now complaining that we don't have a toDoc, but that comes from the pre-printer document. So let's grab that. All right, getting a lot less errors now. Looks like we need a top level tuple function that we can go steal back. We need a constant called indent that we can go steal from the other file. Here's another one, some iter tools. So we're going to import those. Looks like right here we're creating a safe type name. So we're going to need to do the same thing in TypeScript. So rather than get rid of this, let's just rename it. So we're going to change it from Erl safe type name to TS safe type name. Oh no, the Rust analyzer did not want to be able to do that for us. All right, that's fine. We can go deal with that later. So we'll also have to create a top level concat to snake case. Also, that also needs to be imported from heck. All right, docvec also needs to be imported. And this is, again, from the pre-printer document. All right. Okay, let's see what is left for us. So let's go grab that tuple function from TypeScript, from JavaScript. And then we also need, oh, sorry, that was from Erlang. That's where we stole the type printer from. So let's steal this. Place this at the top level for ourselves. Let's see, is break defined? Yep, also from our preprinter. So we'll grab that. We need to find that concat function because that seems to be used in a bunch of places. So let us jump back to Erlang, find concat, go to the definition. All right, grab that, jump back to TypeScript, and we're going to paste it in here so that we also have it. Now, is this the best way to program? Probably not, but for a new project like this, where I'm very unfamiliar, I don't know how to necessarily write this from scratch, copy pasting is going to be your best friend. Kind of until you get your feet wet, I find just copy pasting and then kind of trying to figure out what happens from here. That's the best important thing we can do here. All right. So we don't have a current module, so let's just get rid of that. See if we can rename this yet. Oh, well, we don't even have Erl safe type name, so that's why that errored out on us before. So let's go grab that. And we're going to paste it in. Now we can finally rename it to TS safe type name. There we go. So now we're calling that. We'll clean this up. As you can see, this is basically listing out things you cannot name a type variable. So these are very different than TypeScripts. So we'll go through and clean this up, but we'll just copy paste it for now. Instead of escape atom here, we're going to call super dot. There's something inside the JavaScript module for this. Let's go take a look. I believe I saw, yeah, is usable JS identifier, which I think is used in maybe escape identifier string. So what we're going to do is actually just call this from the other module. So if we jump into TypeScript, oop, that is the wrong thing. My paste buffer. There we go. All right, and there we go. Now we can piggyback off of what JavaScript's doing. So ultimately what this is going to do is we want to make sure we're giving a proper name for a type variable here. So eventually I'll go look up what all the reserved type names are in TypeScript. We'll put that in here. Otherwise, we'll just fall back to maybe escaping the identifier string that's already defined in JavaScript when it does not match. And what is it complaining about? So we need to convert this from a string into a %. So I think that's how you may be able to do that. Yeah. All right. Okay, let's go finally grab that indent from Erlang. And we maybe be, after that, we may be very close to finishing all of this stuff. So let's jump back to TypeScript. Whoops. Okay. All right, this seems like a place that we can starting to modify things. So first off, we can kind of do the equivalent. So the prelude types here are the types that are built into Gleam. So these are things like nil, int, string, bool, float. These are all defined by Gleam itself. They're not actually programmer defined. So let's quickly just jump through these. So here, TypeScript, we don't have the idea of float, the difference between float, integer, or UTF code point. We only have numbers. So we're also just going to add float to this list. String is string, Boolean is Boolean, bit string. We do not actually have a thing for this, but I believe if we actually look inside the prelude for Gleam, so when Gleam actually generates JavaScript today, it does actually include a single TypeScript definition file, and it's this prelude.d.ts. So the built-in types to Gleam will be exported. If we take a look at that, you can see that it does define a bit string type. And so what we'll need to make sure we do is actually refer to that. Let's see. Ooh, okay, we also have a UTF code point type. We have a result type. Is there any other in here? Oh, list type. Okay, so we'll make sure that we'll piggyback off of these for the most part. So let's jump back to TypeScript. So int and float are going to go to number, but it looks like UTF code point already has a thing in the prelude file. So we'll just piggyback off of that. Bit string is the same thing. All right. And this is going to be a list. And the way how we do generics is not through parentheses, but through brackets. I can speak. All right. And what this is doing is basically grabbing the inner type, the first argument of the list. And we'll go into that in just a sec. And we're just going to type print that into here as well. And then we have this result type. And let's see what it's doing here. So it is grabbing, the result type takes two arguments, the OK and the error. And looks like what we're doing here is pulling those out. And then looks like we're generating a tuple of the string OK and OK, error and error. And then it is combining these all into one. So we don't actually need to do this. We actually need to do this kind of like this. So instead, what we're going to do is do this list. But instead of list, this is going to be result. And then what we need to do is, instead of calling .append a bunch of times, we do have this docvec that we can kind of piggyback on. I know I said piggyback a million times at this point. So we're going to do result open. Then we need to print out arg0 or the, arg OK. And then arg error. And then we close our type here and we finish the docvec, and then we can get rid of all this. All right. And all right, so we just handled the preludes. Pretty good work so far. Now we get to work on some of the, figure out the actual type system. Now that the preludes are out of the way, we know what that is in TypeScript. And that. Looks like we missed grabbing this nil function and ID to typevar. So let's go back. Let's find nil. I said nil. Yep, want that. And we're just going to keep sticking these down here. And we also want the ID to typevar. All right, this looks a little complicated, but we'll just copy paste it regardless. When rendering a type variable into a TypeScript type, we need all the type variables with the ID, with the same ID, to end up with the same name in the registered TypeScript. This function converts a usize to base 64 AZ through this purpose. So what we're going to see is the way how Gleam does this is types actually have an ID underneath the hood. And what this is going to do is take that ID and turn it into an actual string that we can refer to. So basically we're taking this, unsigned integer and turning it into a string. And that's ultimately what this is doing. Maybe we can come up with a better system for this for TypeScript, but this all looks fine to me. All right. So how does the how does the Gleam type system even work? So all of that is actually defined in this file here, type.rs or type_rs. And inside here, we actually have this type enum. And so the type enum actually defines only 4 top-level types, which is kind of crazy that the entire type system is based out of these 4 very basic building blocks. So we have our app type, and this is basically where the majority of types kind of go into. A type has a name. If it takes any generics, they'll all go in the arguments here, and they come from a module. And then a function type is actually just a defines the arguments of a function and the return type. Then we have a var, which we'll go into just a bit, but skipping that, going to the simple version, we have a tuple type. So tuple type, just like a TypeScript, allows you to kind of define a heterogeneous fixed width list of items. So var here is type var. So if we follow what type var is, so for here you can see we don't necessarily in Gleam want to have to type every single variable. Like we don't want to have to write that every place. We also want to be able to say this. And what the type var lets you do is say, hey, this is going to be unbound, as in we don't yet know what this is, but then the type inference is going to go and realize, oh, this is a pattern matching against a integer on the right-hand side. So we are going to eventually know to turn this into an int type. And this is kind of how it does that. So everything starts unbound in the beginning, and then eventually as the type checker is going through and kind of inferring things, it will materialize those unbound to links. And then we also have generic types. So this is how it's modeled underneath the hood for generic types. So this is here's the underlying Gleam code. So if you have a record type that actually takes an argument, this generic argument here, we need some way to express this in the type system. The A in this part here is generic. And so that's what this generic system is here for. And all generics have an ID. Yep, so unbounds and generics have IDs. And that was that ID to string function that we saw before. So that was a very rough overview of this stuff. Feel free to kind of like read these comments or trace through the code yourself to better understand the type system. It's super duper interesting and works super well as well. But now that we know that, so what this print is doing is basically taking in one of these incoming types and then saying, okay, well, when we have a type of X, how do we actually print that? So we're getting this incoming type. And if it's a var type, then we're going to call print var. If it's an application type, we're going to grab the name, what module it came from, and any arguments it has. And if the module is empty, which means that it came from our prelude, because it wasn't a programmer-defined application type, we know we're going to print that prelude type. If instead this is a programmer-defined application type, then we're going to print the type app. Finally, we have a print function, and we don't even have a print tuple here. We're just using that tuple helper that we had before, grabbing those elements and mapping them into their underlying printed form. So you can kind of see, ultimately, print takes a type and produces a document. And this is from the pretty print. So this is the pretty print document that we're ultimately generating. So let's take a look at print var. So this is that kind of more complicated type, the underlying variable type. So if we get a generic, or if it's unbound, and let's get rid of this self for now, we're just going to print an any, because we have no idea what this is. Hopefully we don't get here. It should be pretty rare that at this point in the AST that there's any unbound type variables, but for safety's sake, we'll handle it and we'll just give an any. Otherwise, oh, this is if we're counting the usages. So let's just get rid of that. We're not going to count usages for us for now. So if it's generic or unbound, we're going to give an any. And if it's a linked type, this means it's already been, the type checker has been able to figure out what is the underlying type. And we're just going to print that type. So simple enough. We already did the print prelude type earlier. So this is just taking those built-in types and doing the TypeScript equivalent. And now we have the hard one. A programmer-defined type. And how are we going to print that into TypeScript? So let's see what's happening already. So first off, it's going through the args. So if this was a type that takes generics, it's going through them and it is combining them with a underscore, or sorry, not an underscore, not even a semicolon, a comma. And then we are going to generate the name, snake cased. Do we like snake case in TypeScript? No, I think we like to camel case. And let's just make sure there's no other snakes. Oh, there already is. Nope. TypeScript, we do like our camel case. Perfect. All right. Turn that into a the TypeScript safe version of it. And then it is going to do print module name, followed by colon, followed by name, args, and that. So that is the Erlang way of doing it, but it's definitely not the TypeScript. We don't actually need to know what module this came from. So instead, what we're going to do is name, and then open the args and close with our braces here, or not braces, our angle brackets. And even this is not quite true, because if we don't take any generics, we actually don't want to omit that. So instead, what I think we're going to do is just a quick if statement. So if args is empty, instead what we're going to do is return, I guess, just the name. Otherwise, we're going to put these in. So if we don't take any generics, or then we can just omit the name. Otherwise, we do have to do this. And we'll see if this is correct. We'll write some tests before we accept this as a solution. Which also means that we don't need to take in the module, because we don't care where this is coming from. Cool. And now it's complaining that we're still passing the module here. Excellent. We don't need a print module name. All right, printing the function. Okay, so this is doing the same thing. It's combining all the args using a comma here, but that is not what we're doing. So what it's doing in Erlang is emitting something that looks like fun, binary. So these are all the type names, but separated by comma. And then coming to, I don't know, some return type. So binary, let's say this is like concat. So it looks like that's how it's doing in Erlang. But if you notice, that's not how we want to do things in TypeScript. Instead, if we're typing a function, it's going to look something like this. X0 is a string, X1 is a string, and it does fat arrow to string. So that's what we need ours to look like. So first off, we cannot have unlabeled arguments. So we do need to give these all a name. So it can't just be concatenating. We do need to actually prefix those concats with a some sort of variable name. And then we need to do a fat arrow, and then we need to do this. All right. That's easy enough. So let's see. Instead, of doing this, we're going to call, we need the actual index here. So the way how you can get the index in Rust is, I believe, from an iterator. Man, this is where I just go through each. I've done it before. I think it starts with an E, but we'll get there. Well, if I think it starts with an E, let's just try doing E. Enumerate. Creates an iterator which gives the current iteration count as well as the next variable. That's exactly. So we want enumerate. And then this is actually now a tuple, as you can see, of usize and a arc to a type. So we can actually pull that out. So we have idx and a now. And so what we want to do is do a docvec here of x idx colon space, and then finally the printed version of that type. And so that will give us something like this. So we'll have x0 for the first one, colon space, the underlying type, then x1 for the second one, colon space, the underlying type. So there we go. So now this looks correct. And then this here, instead of, we just need a, I said we just need a open paren. Well, you know what? Let's just do this as a docvec. I like that API. So we have an open paren followed by our args, followed by a close paren, colon space, our return type. Ooh, no, sorry, not colon space. This is a function type, which is different than a named function. So for that, we'll just need to close fat arrow space and then the return type, and then we're done. So we can get rid of this. All right, so we printed our functions. And is there any more errors in here? Yeah, so we have our type printer is all free, no errors. Now we just have to do the compiler. So that was easy. Type printer is nice. So let's go see how JavaScript compiles itself. Like I said before, we don't actually need all those bits that were inside there, but we do need those top level statements. So in Gleam, the way how it's modeled is the top level bits are going to be statements, and each statement can be have many expressions inside of them. So let us look at the compile function, which I believe, yep, instantiates this generator and then calls compile. But do we need that? Well, we'll find out. And we're going to do the same thing. We're just going to copy paste all of this. Probably deleting most of it. Copy that. Go to our TypeScript. Paste that result. Oops. Inside there. And because we're no longer doing this inside of a, they're not called record types in Rust, but they are called something. Because we're not inside an actual object here, instead of calling self everything, we're just going to call these as a top level function. So instead of doing self dot, we're just going to call statement. Do we need to collect these imports? Let's just comment that out for now. And as you can see, instead of calling self.module, we're just going to refer to the module variable. Okay, looks fine. These are all tracking of usage to see if whether we need to import them. I don't know if we'll need that. Maybe we'll add this back in, but for now, we're just going to delete it all. I see. So what's happening here is after we found out what we need to import, if it's empty and the statements are empty, we're just going to emit kind of a empty export from that JavaScript, but which kind of sounds like the same for TypeScript, to be honest. And if the imports are empty, it's just going to push to the statements an empty a new line and then return that. And if the statements are empty, it's just going to, got it, turn the imports into something. Otherwise, it's going to do imports, new line, statements, new line. Okay, so maybe we do need those imports. Yeah, we'll see. Again, this has to do with registering usage, and I think I'm just going to delete that for now. Okay, so now we have our statements. So there's only a few top-level statements in Gleam that we have to worry about. Oh, does not want to be able to go to that because I think I have a broken file, but I know which file it's defined in. So if we look for capital S statement. All right, so these are the top-level statements available to us in Gleam. So we can have a function statement. We can have a type alias. We can have a custom type. And we can have a external function. So this is how we can call functions that are defined in Erlang land or JavaScript land, depending what our target is. And we have external types as well. And finally, we can have imports to other modules. Oh, and also module constants. Okay. So these all look good to me. And thankfully, we don't need to go much further than just these statements. But let's take a look at where we're at. So we get this type statement coming at us. Going to get rid of that self input and make this private function. By the way, the indentation of all this is now wrong. So I'm just going to quickly indent down, and that helps me find which parentheses probably need to go away. There we go. Get rid of these self. We're not going to do that. We don't need this register and scope. Get rid of the self. Okay. Okay, there we go. So let's go into our statement function. Okay, and now I think we are in a better place. What is output? I think output is a defined thing in JavaScript. I think output is a type alias. Yep, here it is. So output here is a result type of document with this generic. So we're just going to copy paste. Actually, we don't even need to copy paste it because it's public. We're just going to grab it from super. So let's find that output again and see if we can import it from super. Yep. Just the self. All right. Oh, and we need to import statement from the AST. That's probably why I couldn't go to it automatically before. Probably need to import this type statement. Yep. This function cannot have a self parameter, but it's not taking a self parameter. Well, let's see when we just keep going through it. I see. Colon self on a lot of these still. Rid of those. Okie dokie. So, if we get a type alias, which, if we remember what this is basically pub type headers is equal to a list of tuples of string. So this is basically us just being able to rename something. Or if we get an external type, it looks like we are not emitting anything. Is that correct here? I think that may be true for external types, that we need to emit nothing, but we do have the idea of a type alias in TypeScript. So I think what we need to do is actually break this apart. On external types, we will return nothing, but when it is a type alias, I do think we do need to render something. So what does type alias have? So we know, it's public or not. So if nothing is public here, we actually don't need to emit anything. If you think about it, if it's not public, there's no reason to add it to the TypeScript definition. So we can skip anything that's not public. So we'll look at the public here. We'll grab the underlying type, and then we also need the name, alias. Okay, so let's grab alias. Let's grab whether it's public, and let's grab the underlying type. And we're going to say, if it's public, we're going to go do a type alias here, passing in the alias and the underlying type. And we need to wrap this in a vector. Otherwise, if it's not public, then we know we don't need to emit anything. And we can just do an empty vector here. Okay. If it's an external type, I just don't think we need to do anything. These are types that are defined inside another system, like JavaScript or TypeScript. What maybe added to do? Come back to that later. If it's an import statement, we may need to import the types into this definition, as types in TypeScript are not global, but that sounds hard. So let's just do that later. Okay, if we are doing a custom type, so here we're defining some sort of ADT. Again, if it's public, we're going to do this. Otherwise, if it's not public, we don't care, because we're not actually defining the how it's actually going to work. That's the other generator's job. We're just defining what the public interface to this module. So otherwise, empty vector, meaning we're not generating anything here. We do not need to pass public down. And what if a type is opaque? Well, we still need to export something, but not sure. TypeScript, unfortunately, does not have opaque types, which is a type whose true definition is only available to the module where it's defined. Otherwise, it is opaque to all other modules. Not sure what we'll do there. I'll have to probably read on what's being generated in the main generator, but we'll pass it down for now. If we're getting a module constant, that sounds good. But again, if it's public, we'll generate this. Don't need to pass that down. And if it's not public, then we'll empty vector it. Same thing for our functions. If it's public, we'll generate this. Otherwise, we will not. And by the way, if you're new to Rust, this 2 dots here just means anything. A statement that has anything in it, I don't care. As long as it's not public, it goes here. So you can see these 2 dots mean, I'm going to extract out these 4 properties but then I'm going to ignore anything else that's in there. And we're not going to pass public down because, again, we're just assuming everything's public. If it's an external function, this means it's a function coming from JavaScript or TypeScript. Do we need to generate something here? I would think not, because we're already in TypeScript land, but there looks like the main generator is doing something when the module is empty. Not sure when that would be. I'm going to do this as well. And this is another thing I do as I'm working on something. I will just to do a bunch of work that I don't yet understand and be like, you know what? That's a problem for future E. Right now, I'm just going to focus on other things. Okie dokie. So this is looking pretty clean. So top to down, tops down here. When we get a type statement, if it's a public type alias, we'll call the type alias function. We don't yet know how to handle external types. We probably do know how to handle imports, but it sounds like it's going to be a lot of work. So let's skip that for now. If it's a custom type in public, we'll do that. If it's a module constant, so this is just like a constant defined at the top of the file, we know how to generate that pretty fast. And same thing for functions. All right, so custom type definition. Let's take a look. I think we need to import this. You know, I'm realizing that because we don't have a box, we don't have access to this generic. Man. All right. I will refactor that later. I think without the box, this generic is never going to work out. So we're always going to have issues. So that'll be a problem for future E. So what we're doing here is we're going to be getting our type record constructors. We don't care. We're not going to take public. And we're going to iterate through those constructors and return a record definition. So this is ultimately going to give a vector to the record definitions that are inside here. And so record definition here, again, we're not going to take public. What this is doing here is we're defining a local function called parameter, which takes in a tuple of an index and a argument. Again, we need to import this one. And then basically from here, we'll grab the label of that argument. We will map. So this is a option of string. So map here is basically going to say if it's defined, we're going to call this. Otherwise, we're not. So here will be, yep, an actual string. This again, we got to call super on. And otherwise, unwrap or else is basically if it was not defined. So if this option was actually an empty, then we're going to call this, which is just going to put x then the I, which is exactly what we did in our other function. So if not opaque, we will do export class. Otherwise, we'll make it private. Interesting. So opaque types are private, it seems. Is this going to be used someplace else in this function? Nope. So it seems if something's opaque, then it's not even emitted as a public thing for you to import. So we don't need to generate a type generation for it. So let's go find our function. Let's go grab opaque out of here as well. And so if it's public and not opaque, then we'll call this. That's confusing. Okay, we're in a module function. Where was I looking at before? Okay, collect imports, record definition. Oh, interesting. So this record definition can also be opaque. That makes sense. Yes, you have an opaque type, you don't have an opaque function. I'm just silly. So this is actually going to be in our custom type. So that's where we need this. If public and not opaque, we're doing this, which means that we don't need to pass the opaque down anymore. Here, we don't need to take opaque. We don't need to pass opaque down. So here, this can go away. So now we don't need to handle any of this. We're always going to export. And we don't need to have this intermediary variable anymore. Now this can just be export class. Interesting about this extends custom type. Looks like that will be something that we'll have to make sure to import. Okay, if we take no arguments, then we will close off this class definition. Makes sense. Otherwise, we will separate our parameters by comma, allowing them to be broken. I believe what the break underscore function does here, it says, hey, pretty printer, you're allowed to break on these things. And if you break with a new line, then it's just a comma. Otherwise, if you don't need to break with a new line, it's comma space. I believe if I understood what this function did, that's what it did. Yep, exactly. So we have the broken and unbroken versions. And so you can see that this is actually generating the constructor body by saying, various indexes. We're going to basically say this at that index is this. Otherwise, if it's named, we're going to do that. But again, we don't care because we're just generating the definitions. So we don't actually need the body of the constructor. We just need the top level bits. So we just need the constructor here. And it's just going to return this. So what we do need to do is we do need to type these parameters. And we also need to pull in this line function. So let's go to JavaScript. Let's find that line function. Nope, I see it. Where is this defined? Okay. Looks good. Let's grab that. Oop. Let's jump back into TypeScript. Let us paste this line function so it is available to us. And we'll put it next to the other formatters. So next to tuple and concat. Also, let's not make these public. Cool. And then I just realized the way how we define tuples in TypeScript is not using squiggly braces or curly braces. We use square braces. So boop, boop, boop. That all looks good now. All right, down to our parameters. So we will have to, I see. So we're mapping this to the parameter function. Yep, right here. Which is going to, I see, just output the identifier, but we need the type of this argument. So yeah, so we need the type of this argument. So we can't just do this maybe escape identifier doc, we then need to assign this to name, which is going to be a prettier document. And then what we need to do is return here a docvec of the name that we found, colon space. And from here, we need the actual print. So we're just going to call TypePrinter. Well, I think I may have messed this one up. TypePrinter, help me out. New.print. Yeah, that seems good. arg.type. Why does this not like me? Nope, need a semicolon. Yes, okay, so we got it right. Okay, so for each parameter, what we've done is we've pulled out the name just using before, and now we've actually done colon space and then the name of the type of the underlying type. And now when we combine them all using commas, we'll get our nice constructor for TypeScript, all pretty like. Yep, and this all looks correct. Collecting the imports, so this is basically going through all of the imports and doing its thing, registering them. We don't have this just yet, so I'm just going to skip it. Import path, same thing. Register import is skipping that. Register external function, skipping that. Module constant. Yep, this one we are definitely going to do. Got to import type constant. Again, we don't need this public. We're always going to do export const. So we can even get rid of this whole head thing, and then this is going to be export const. We need our colon space here. Then we need to do our type printer. Did that work? First try? Oh my god, it worked first try. So export const, super this. So we can use that from JavaScript. And we don't actually need this equal sign or the expression. Because again, ultimately what we want to do is export const foo is a number. We don't actually need to say what number that is. TypeScript doesn't care what number it is. It just cares that it is a number. All right. And what I think we'll do is we'll just finish up these module functions and call it a quits after that. And then I can maybe in a part 2 go through, clean this all up. I'm noticing that this is already over an hour-long video, and we have not really accomplished much other than you can kind of see how I'm navigating the project and such. All right. So last push here, module function. We get our name, we get our args. We got to import typed arg. And we also need to import typed expression. Okie dokie. We do not need our expression generator because again, we don't care about what's inside of us. We are always going to be exporting because we're always public here. We do not care about the body. This is a super. This we can just get rid of. Export function space. Yep, we do want to do these function args. Generator tail recursion used. I don't think we care. And so if we look at what it should look like in text in TypeScript, this would look like export function foo, which takes a, which is a string, and now it's using that colon because it's a named function, which outputs a string, then a semicolon. So that's all we need to do for TypeScript. So we don't need this open squiggly. We can get rid of that. Export function, that name, function args, which is going to do the parens for us. And then what we need is the return type. So we don't need any of this. And instead, we're going to grab our TypePrinter. Aren't we glad that we did all that work up front? And we're going to print, after the args, that will be a colon space. Then we'll print our return type, which was not passed to us. So wherever calls module function, we need that return type. And we need to, instead of passing the body, we're going to pass in that return type. And this is I believe, a type, but we'll let Rust yell at me if I got it wrong. But that means we just get to print our return type. And finally, we get to finish the whole thing with a semicolon. Cool. That all looks good. Ooh, we have not implemented function args. Fine, we'll do that real fast. Grab our function args. Find the rest of our formatters right here. We do not need this tail recursion used. Means we can get rid of that. Oh no. We don't have a, okay. I probably should have just been using super for all of these before. Another thing to fix. Okay. Get variable name. If we didn't get a variable name and discards is equal to 0, then we'll just use the underscore. Otherwise, we'll do underscore then that thing and increase discards. Yep, makes sense. Otherwise, we just do this. But again, all this is doing is outputting the identifier doc. But what we actually need is a docvec of not just the name, but also a colon space, followed by our TypePrinter. Printing the actual type of this thing. So that would be a.type underscore or type like that. There we go. And now the wrap args should totally be fine. And now we actually put the type inside this function args. There was a reason why we didn't just call super. Okie dokie. So now our module functions should be totally fine and outputting the right stuff. And do we want to do global external function? Do not, because we do not know what this is yet. Okay, I'm going to call it here. Got a lot less accomplished than I had hoped, but I hope this was a good overview of Gleam and how you may go about this. I'll definitely come out with a part 2 video of me kind of taking it the rest from here, but I definitely need a break. You probably need a break. And if you made it this far, thank you so much. Definitely go check out Gleam. It's a really cool language. It's gleam.run is the website. And then also join us in Discord. It's very active, and if you ever wanted to kind of get started hacking on a language, I think Gleam is a great place to start. All right. Cheers, y'all.